So for the final lesson of chapter 9, we're just looking at compositions of transformations, which simply means you're doing two transformations. There's only three transformations that we look at, that we've already looked at. The translation, reflection, and rotation. So what you're going to see in this section is simply doing two of those things to a shape. And so there's really nothing new to this. It's just a matter of doing two transformations rather than one. So if you'll look at the example that they already got for you here, they started out with triangle ABC, and they're going to find its image after doing a translation. So they're going to translate it along this vector, and then from there, they're then going to reflect that across the x-axis. And so we're going to do two things with this one. So here was the first one. I do want you to remember that this is vector notation, and this simply means I'm going to subtract 2 from my x's, and I'm going to subtract 1 from my y values. So for this translation, right, they wrote it as a vector, so it looks like this. We probably would best see it like this, but you could write it either way. They mean the same thing. So they're going to take those original 3 vertices, and they're going to apply this rule. So they subtracted 2, so here's the original ones. They subtracted 2 from all of the x's, and they subtracted 1 from all of the y values in order to get these points right here. From there, they're going to take that answer and reflect those numbers across the x-axis. So remember, when you reflect something across the x-axis, the rule is the y value changes his sign. So here's a good thing to remember, that xy is going to become x negative y, or the opposite of y. So we're just changing the sign of the y value, but do keep in mind for this step, we're not going from here, we're going from our previous answers, right? So these guys have been translated according to that rule, and this is where they're at now. And so then from here, we're going to take these numbers and change their y-coordinates, change the sign of their y-coordinates, so that these can be reflected across the x-axis. And so if we do that, this is where we would end up. So if you look at the graph, I'm going to just pick on one point here, so hopefully it will kind of stand out of what took place. So here was point A. This is where it started, right? This was just one of the vertices of the original triangle. So you can kind of see it here is A, B, and C. It's just a little tough because you got 3 shapes all overlapping each other. But look at point A. You can see what it did. It went left 2 and down 1. So from here it went left 2 and down 1. And notice on that one, after the first move that they make, they put a prime, just like we've been doing before. But then from there, they're then going to reflect that point across the x-axis. So I'm going to take that value from A. It was 2 units above the x-axis. I'm going to reflect it so that now it's 2 units below the x-axis, and that's where I'm ending up. Notice on this graph, to show the difference in the points, after the second move, they now put a double prime. So now they put 2 prime marks to show that it's the second action that took place. It's the second transformation. So that's how you can always distinguish between the 3 points, right? A is the original, A prime was the first transformation, and then a double prime was after the second transformation. So this is where we're going to end up on these guys. So as we look down, one thing I want you to mention on this that's going to come up on our test is keep in mind with any shape, but we are kind of trying to focus a little bit on triangles because that's what our next chapter is going to be about. Chapter 4 is all about triangles. And one of the things that they want us to really grab onto this chapter is the idea of isometry, right? I've mentioned this one in a couple of the lessons, but the idea of isometry is when you do these transformations, they produce congruent triangles. So if I look at the triangle where I ended up and compare it to the triangle that I started with, then we have 2 congruent triangles. So the new triangle, all 3 segments and all 3 vertices are congruent to the original triangle's segments and vertices. We call those corresponding parts, right? So if I look at C double prime, he corresponds with C, the original C, right? So those are corresponding parts, and they are congruent to each other. And I could do that with all the segments and all the angles, right? They're all congruent to their corresponding parts of the original triangle. So these guys do not change as we move them. They're just going to a new location, but the shape itself won't look any different. So let's try that with a couple. On number 1 here, we're going to do a translation. So we're going to go right 1 and up 2, because they're both positive. And then from there, I'll do the reflection in the y-axis. So a couple ways you can do this that I've already talked about is you could write all of this down without the graph if you just use the rules, right? I know based on this that I can take all 3 of these points. I can add 1 to the x's. I can add 2 to the y values. And that will give me the first transformation. From there, I could then apply this rule and change the sign of all of my x coordinates and get the final image. So I could do that without graphing it, but we're going to practice both, right? So we're going to practice the graph and we're going to practice using the rules. The graphs are a great visual, and it helps to see what's going on. So as I look at this one right here, again, let me just do this with one of the values. Let's take point x as an example. So x started out as 6, 5, right? So x prime would be what? So if I use this rule, the first thing I'm going to do is add 1 to my x value, which is 6 going to 7. Then I'm going to add 2 to my y value. So 5 goes to 7 also. So this would be x prime. So after I graph this guy and I go right 1, up 2, this should be the point where I would put x prime. And then from there, we're going to end up with x double prime, which is to take these numbers and reflect them across the y-axis. Now, remember, the rule for reflecting across the y-axis is to change the sign of your x coordinate. So it's going to become negative 7, 7. And that's going to be our final point. And so we could do that with all 3 vertices, right? We could write the numbers down that way, and we could literally do it without a graph. But you're going to be asked to graph too, so I want to do both of these. And not to mention, some people do this better visually rather than applying the rules anyway. So let's take a look. So I'm going to start by just graphing the original 3. So I have x at 6, 5. So here is my x. And then I'm going to have y at 7, negative 4. I'm trying to blot that out a little bit. There's not supposed to be a prime mark there. These are the originals. So there's the original x, original y. Original z is going to go at 5, negative 5. All right, so these are my pre-images. Here's my z. So this is the original triangle that we're starting with. Good enough. So, all right, so there's the pre-image. I'm going to use a blue pen here. Hopefully this will help a little bit to do my translation. So again, I added 1 to the x's, which means I'm going to go right 1. I added 2 to the y's, which means I'll go up 2. So I'm going to take every point and go right 1, up 2. So x prime is going to go here. Right 1, up 2. So here's y prime. And then right 1, up 2. Here is z prime. All right, so notice on this one, again, still congruent triangles. Nothing has changed about my shape. All it did was slide to the right and up, right? So I still have 2 congruent triangles, and then from there I'm going to reflect those points across the y-axis. So I could apply the rule like I did here, right? I could just say, well, let's just change the sign of my x, and it's going to be negative 7, 7. So if I just applied the rule, that would tell me where to put x double prime. If you're more of a visual person, You could have just said, well, I don't know what the rule is, but I'm just going to count. I know that if I reflect it across the y-axis, well, as of right now, it's 7 units to the right. So in the reflection, it's going to be 7 units to the left, right? And so I could identify it that way, even if I didn't remember the rule. I could do it by just graphing it. So let's do the same thing with y and z. So again, I know for my y value, right now it's 8 units to the right. It's going to move to 8 units to the left of the y-axis. So here is my y double prime, and z was, 6 units to the right. So I'm going to move him 6 units to the left. So here is my z double prime. And again, make sure we're moving from our last step there. And I meant to do these ones in a different color, but that's okay. I'll at least do the triangle in a different color. There we go. So that red triangle is basically our answer, right? That is the image after this glide reflection, right? So they call it a glide reflection. That's just a fancy name given to the two-step process for when you do a translation, then a reflection. They call that a glide reflection. So anyway, this is our final image where we ended up. And again, make sure if you're graphing these that you always show the notation like this, right? So we can always distinguish between where we started and then our first move and then our second move, right? So make sure we note those properly. Let's try one with a rotation involved. So in this one, we're going to start with the same set of points. So I'm going to start with, again, my x at 6, 5. So I'm going to start with my x right here. I'm going to start with my y at 7, negative 4. And my z at 5, negative 5. All right, so here's the original triangle. Looking like this. And so we're going to take that guy, and I'm going to use my blue pen here to do the first transformation, which is to go positive 2 and then up nothing. So in other words, I'm just going right 2. And that's all that's going to happen on this one. So x prime is going to go right there. Y prime is going to go right there. And z prime will go right there. So everything just went right 2 units. There's my new triangle. So again, still a congruent figure, just went to the right 2 units. From there, I'm going to rotate it 180 degrees. So again, the rotation was the one section. That was our last lesson. That was the one I said can be pretty challenging to do visually. I really recommend knowing the rules when you do rotations. Our 180 rule was that AB becomes negative A, negative B. So it's just a sign change for both coordinates. So if I were to take a point like X, which is currently at 8, 5, so 8, 5 is going to become negative 8, negative 5. So I'm going to go negative 8, negative 5. And so for those guys, for the rotations, I really recommend just applying the rule because it can be tough to do that rotation visually. So my X double prime should finish off here. And let's do the same thing with y prime. Y prime is currently at 9, negative 4. So again, if I just apply this rule, 9, negative 4 is going to become negative 9, positive 4. Remember, one thing that we did mention on these that might help you is just to remember that when you do a 180 rotation, I know that my points should end up 2 quadrants away from where I'm starting. So my X right now is in quadrant 1. So after a 180 rotation, he should end up in quadrant 3. My Y and Z are both in quadrant 4. Both of those guys should end up in quadrant 2. Right, so that's just a simple check, just to kind of help make sure we're on the right track. So Z prime currently is at 7, negative 5. Let's apply the sign change. It's going to become negative 7, positive 5. And he's going to end up right there. Give it the double prime. So again, the red one is kind of my official answer. The blue one is just a step in the process, right? So really this one is where everything finished up. This would be our image after those two transformations. So let's peek at two more for practice. I'm going to throw another set of problems at us just for practice here, so feel free to pause and try these ahead of me. I'll go through these fairly quickly for you. I'm going to take those same triangle marks. So we got x was at 6, 5. So this was our x. Our y value was at 7, negative 4. And z was at 5, negative 5. All right, so there's the original. We're going to apply a couple transformations on this guy. So on this one, and again, guys, just as an example, if you were asked to find the image and you don't want to graph it because maybe in some problems all they're going to ask you for is the answer, like the ordered pair for where this thing ends up. So one approach that you could do if you don't have to graph it would be to do something like this. Get that mark out of there. So I know that like my x value started at 6, 5. So without even graphing, I can look at my rules and say, well, according to that rule, I'm going to subtract 3 from my x. So I get this, and I'm going to add 4 to my y value. So 5 is going to go up to 9. So my first move, it's going to end up here. From there, if I want to apply my reflection rule, I can say, well, if I reflect in the x-axis, I know all I have to do is change the sign of my y-coordinate. So I know this positive 9 is going to become negative 9. So my finished answer is going to be right there. And so we could certainly do that without graphing if we know the rules. And so that's an option. So if you're given a question where you don't have to graph it, then you can take this approach and not graph it. But I know some people are just better visually anyway and would rather not memorize the rules. And so they'd rather just go through the graph, and that's fine too. So I'm going to take my point for x. I'm going to go left 3, since it's negative, and up 4. 1, 2, 3, 1, 2, 3, 4. So here's where x prime is going. Let's do the same thing with these guys. 1, 2, 3, 1, 2, 3, 4. One, two, three, 1, 2, 3, 4. So here's where we're at after our first transformation. And then now I can do the reflection in the x-axis. Do keep in mind on this, our y value is not going to move because he is on the x-axis. So there's nowhere for him to go. If you feel like you're standing on the mirror, right, it's like you're touching your own reflection. So not going to go anywhere from there. However, the z was 1 unit below. He's now going to be 1 unit above the x-axis. Our x value was 9 units above it, and now he's going to be 9 units below it. So that's where he'll finish. So if I connect the dots, then this red figure is going to be our final product. And you can see kind of that perfect symmetry that it makes with the x-axis as you look at that new shape. But that's it. So, and then from there, if I needed to identify the coordinates, I would just look at where these numbers are now. So if I wanted to know the answer for y double prime, I could simply look at my graph and say, okay, he's at 4, 0. Z double prime is at 2, 1. And so I could just pick my answer right off the graph. And then one more for practice. I always like to throw in a little more with rotations because those tend to be the toughest for people. So if I look at my translation, let me just graph the original points. So X is going to be at 6, 5 again. So he is starting right there. Our Y value was at 7, negative 4. Z's at 5, negative 5. All right, so there's that original triangle one more time. So let's go to the blue one first. We're going to go left 1, up 3 for each of these. So after we do that shift, that translation, that's where we're at. So everything, that whole graph just went left 1 and up 3. Now I'm going to rotate at 90. Again, these are the ones I recommend knowing the rules for. If you look back at what we did in our last lesson, remember these are the 3 rules that we mentioned for this. So our 90 rule is where AB becomes negative BA. So again, I'm going to say AB becomes negative BA. So that's the rule that we're going to apply. So again, I'm going to look at a point like X prime. That's where I'm at now. And I'm going to identify his coordinates. So I'm going to say right now he is at 5, 8. So if X prime is at 5, 8, where is X double prime going to be? So if I apply this rule, remember this means they're going to trade places, and the guy that was here, as he goes to the front, is going to change signs as well. So my 8, 5 are going to switch, but as the 8 comes to the front, he is going to become negative 8. And so here's where X double prime should end up. And again, 90 degrees means they should all move 1 quadrant in my counterclockwise direction. And so that worked out just like I expected it to. So let's do the same thing for our Y. Currently, Y prime is at 6, negative 1. So where is he going to? So again, those guys are going to trade places. That negative 1, as it moves to the front, is going to become positive 1. So Y prime should be at 1, 6. Y double prime. And then one last person here, we got Z. Z is currently at 4, negative 2. And so Z double prime should be, again, these guys are going to trade places. My negative 2 becomes positive as it moves to the front. So 2, 4 should put me right there. Guys, again, as you notice, and one thing I really like about the graphing approach to this is it's a way of kind of checking your answer too. As I look at my finished product, again, it should look identical to the shape that I started with, right? It's the same triangle. It's the same. All of my lengths are the same and all of my angles are the same once I'm finished. And so I can tell that I was definitely on the right track with my answer simply by looking at where I finished and where I started. It's a great visual way of kind of checking to make sure that we did it right. But that is the end of chapter 9.